All right, so boom, you walk into calculus, you're fresh off derivatives, and then you see it. Your first related rate problem. Let's break it down. A person whose height is 6 feet is walking away from the base of a streetlight along a straight path at a rate of 4 feet per second. If the height of the streetlight is 15 feet, what is the rate at which the person's shadow is lengthening? Okay, let's label off our unknowns. We do not know the length between the person and the street lamp. Let's label that as A. And we don't know the length of the shadow. Let's label that as B. But we do know the rate at which the length between the person and the street lamp is increasing. That's going to be 4 feet per second. Because if the person is walking away at 4 feet per second, then the gap between the person and the street lamp is also increasing at 4 feet per second. So that's our A prime. Now we just need to find a way to relate our A prime to our needed B prime, the rate of the shadow increase. But how do we do that? That's going to be with similar triangles. The triangle with 15 feet and the floor is going to be related to the triangle of 6 feet and the floor. Because the light passes through the top of the light bulb, through the top of the person's head, all the way to the floor, meaning that both of the triangles created from the perpendicular lines from the floor to the ground are going to share the same angle. And using that, we're able to create a ratio. 15 over A plus B is equal to 6 over B. And then from there, we're able to solve for B and then derivatize both sides. A prime times 2/3 equals B prime. We already have our A prime, it equals 4. So 2/3 times 4 equals 8/3. That should correspond to answer B.